Welcome to CCNA. This is Ryan. And today we're going to troubleshoot an enterprise network. Sounds kind of intimidating, but in truth, they tell you exactly what's wrong. So rather than an exercise of going through the troubleshooting steps, they kind of walk you through the steps to solve certain issues. So we'll start out, we'll do this in 4 parts. But part 1, we're going to verify the switching technologies. So we've got switches in this network, and the idea there is to aggregate a bunch of end devices. So we're going to start looking here at switch number 1, and what we want is a little bit of port security. So open this up. And according to this, switch S1 is supposed to be limiting the number of devices that can be attached to each switch port. And if we do the command it says in here, show port security. Oh no. Yeah, it's not a mistake. There's no port security configured, so we need to go in and configure that. So we go into global configuration mode, and then we can go. Well, right now there's only one device connected, so we could just do that one interface. I don't want. So you could just configure port security on every single port with the by configuring the group of interfaces, but we're just going to rather than doing the range, we'll do the interface phase 03 like it says. If we go off the reservation, sometimes the scoring doesn't work. It's always satisfying to get up to that 100%. All right, so we're in interface configuration mode for phase 03, and in case you didn't know, phase 03 is the one that this PC is connected to. We can hover over the cable and we can find that out. They label it on here too, but these up. They won't let you move them around, which is good. This isn't directly connected to how things are configured. It's just a text box. So that's one of the nice things about packet tracers, that you get the physical topology. You don't have to do hand over hand with cables and stuff like that. All right, so we're back to S1. It's taking a while, but we're going to put in the command finally. Switch port security. So we've enabled port security, but now we want it to learn the MAC address and then put it into the running configuration. So we're going to do the switch port security MAC address, and then we can put in a specific MAC address, but we're going to let it just remember the first MAC address that comes to it. And you'll notice that we're already at 8% completion. All right, so now it should still not show anything, right? Oh, no. It does. All right. I thought it would require us to send a packet first, but apparently not. So whenever we get a security violation, the port will shut down, and that's what we want, apparently. So the next thing we need to do is look at the VLAN configuration. Apparently, we've put everything onto VLAN 10. So if we do the show VLANs, that's what we should see. If we look at VLAN 10, there's FA03. There's another port there, but if we look at this, ooh, it's gigabit Ethernet 01, which is not FA or fast Ethernet 04. So no good. And you'll notice that it walks us through that, and then it tells us what we need to do to fix that. So what we're going to do first is show you the simple PDU. So this little envelope here is the same thing as typing a ping into the console for PC1, but it's just more visual. So if we try to ping the router or our default gateway, so it fails. Sometimes it'll fail the first time because of ARP, so you need to do it twice just to be sure. But you have to click on it. There you go. All right, so it failed 2 times. So right now we can't get to the default gateway, and we know that the reason for that is that Gigabit Ethernet 01 is on a different VLAN. Just make sure it's 01. I mean, they'll tell us in here, but helps to be able to visualize that. All right, so we need to get Gigabit Ethernet 01 into VLAN 10 that we've named V10 for redundancy, I guess. Let's get into global configuration mode and then interface configuration mode. So we want interface Gigabit Ethernet 01. And right now we're right here on the instructions. And we'll do this first part first and do the ping again. So we're going to access, or we're going to take this, put it into VLAN 10. The do command lets you run things. Or lets you do the show commands and other modes. Great. So if we do show VLAN again, you can see I got Gigabit Ethernet 01. It's in VLAN 10. It's taking a little while to come up, and that's because it's going through the spanning tree process. If you put it into port fast right away, it would come up right away. Where it's going to show that by fast forwarding, it's fast forwarding. It's either fast forwarding a second at a time or this fast forward button doesn't work. It's not fast forwarding a second at a time. It's making me wait. This is evil. How am I supposed to make points? There we go. All right. So spanning tree went through its thing. Now if we go through and do the little ping test there. First one fails because it pretends like it's doing ARP. Yeah, it's failing again. That's not good. Oh, well, we don't have a DHCP address yet. All right, another problem is with DHCP. So if we look at this thing. So we fixed one problem, and we have multiple problems to fix. Let's do the desktop. If we look at the IP configuration, we don't have a default gateway. And we have the auto config IP address starts in 169, so that's not good. We could refresh that, but it's supposed to be in another step, so we'll wait for that. And in the meantime, we'll put in the port fast. So the spanning tree port fasting, remember how we had to wait for the port to go through spanning tree before the little triangle turned green. Now, if we do the spanning tree port fast, we won't have to wait for that. It gives us a warning because if you're connected to another switch and you port fast this port, it won't do spanning tree, and you can create a loop. So loops are bad. Don't do those. It tells us immediately after to do the IP config renew, and what that will do is get us our IP address and default gateway. Oh, to do a slash. It will get its DHCP address and default gateway. And now if we go back, do the, well, actually, let's do the ping with the, we'll do it this way first, and then we'll do it. So successful, and then if we go here and we go to the command prompt, we, the same thing would be to type in ping 192.168.10.1. There we go. So it'll send 4 pings and then let you know the results. Great. Okay, so we've got this guy working now. And what we want to do is look at this switch block. So we've moved over to these switches over here, and we're looking at these channel groups. So it says that you should just turn on the ether channels manually, not use PAGP or protocols for aggregating them. So we'll start with switch number 3, and what do I want to look at first? The ether channel summary. So we moved on. We're here at this switch S3. If we do show ether channel summary, we can see that one of our ether channels, group 1, is just not happy. Which is funny because these little things are blinking. Must just be the layer 2 connection. I guess these are layer 2 ether channels, but the ports are up, but they're not part of the ether channel, and we need to get them that way. So we're going to do this one, where we go into the interface range this time and turn them on. So you don't have to do the interface range. You can go into each interface individually. It's only 2 interfaces. It's not that big of a deal, except it's a little more elegant this way, especially since it's an ether channel, and it'd be nice to see them come up at the same time. All right, so we're doing fast Ethernet 1 and fast Ethernet 2. You can see from our show command that 3 and 4 are in an ether channel, but 1 and 2 aren't. And if we look here, there's 1, and there's 2, 2, 2. There it is. Okay. So we're going to take those. Enter. You get in a global configuration mode first. Somehow I thought we were already there. There we go. And we do channel group 1 mode on. So we're just turning on the ether channel. We could, there's other modes that we could put that into that would change whether we're using PAGP or LACP. PAGP is the Cisco one, and then LACP is the standards-based one. And those are good. They're good protocols. No reason not to use them, but it's just simpler just to turn them on. So if we get out of this, we can do the show interface trunk. Oh, well, we should probably look at the ether channel first again. And there we can see the two interfaces have gone in. And if you don't know what the little letters mean, you can go up here to the what the flags mean. And P means it's in the port channel, and S means it's layer 2, and U means it's in use. So these are letters you want to see when your ether channel is working. Okay, so we're gonna look at the trunking. So to make sure that all these different VLANs can get in between these switches, we need to set up trunks. And let's just make sure, yeah, it's switch 3 that we want to look at. And looks like trunking's on. That's good. And we're allowing pretty much every VLAN. So it should be good for there. If we go over to switch 2, let's see what we see. Switch 3, and then we go to switch 2. And enable show interface trunk. Well, we can see there's a native VLAN issue. So normally you get this annoying console message, but maybe it's simulating that we're telnetting into this. We're and in that case, you wouldn't necessarily get the console message. So yeah, if we look at this, yeah, we're trunking and all, but yeah, the native VLAN isn't right. So it tells us to correct the issue. So conf T. In case you were wondering, interface Gigabit Ethernet 01 is the one right here. It's what you would call a router on a stick. Since it's got a bunch of sub interfaces. So switch port, trunk, native VLAN 10. Oh, 99. That's better if you follow the instructions. All right, and we went up in percentage, so we know we're on the right track. Great. So again, the native VLAN is kind of a vestigial feature, but best practice is to make it to a non-default VLAN. And VLAN 99 is the one that we use in this packet tracer. What we haven't been doing is saving. It doesn't tell you, it doesn't score whether or not you do this, but Every time you make a change and it works, you should probably save it. Copy, run, start. And if we were, doing this right, we would go back to every single switch and do that. All right, so now we're moving on to a different issue. Remember, spanning tree. We've got a triangle of switches here, which means redundant paths to get to switch 2. And the main thing that we want to make sure is that switch 2 is the root switch for spanning tree. So what happens in spanning tree is that one of the redundant paths is going to get blocked, so that if we send packets over to switch 2, they don't keep going around in a circle. So ideally, we would want switch 4 having the primary path going to switch 2, and switch 3 having a primary path going to switch 2, and then this would be blocked. But that only happens if switch 2 is the root switch. So if we look at switch 2, spanning tree, totals. It's going to say switches in PVST mode, and there's it's not the root. So root bridge for no VLANs. So yeah, per VLAN spanning tree is what PVST stands for. So in that way, you could potentially load balance. Oh. So we need to change the spanning tree so that switch 2 is the root for every single VLAN. We get into global configuration mode and then do the spanning tree VLAN 1. There we go. And we could do this with priority numbers too. To go back one. Priority, yeah, you could do priority numbers, but we're just going to say we want this to be primary root, and it won't set it to the best priority, but it will. It'll make it root compared to everything else. So just take that long to process that. Yeah, it's taking a little while. All right, so while it processes that, we're going to look at the same show command again, and it should show up now. What? Oh, we're in configuration mode. All right, so we get out of configuration mode. Look at the spanning tree again, and now we are root bridge for all known VLANs, which is great because that will make the path more efficient. Though it looks like those two are still blocked. There we go. They came unblocked. These guys should get blocked, but maybe it's lazy about showing that. Blocking on 3 ports. So why would we be blocking on switch 2? We shouldn't be blocking. Oh, it was blocking before. Now it's not blocking. Phew. Okay. Great. And that's it. Okay, so we're about halfway done. No, we've only been through one part. So we're going to hold this recording, and then we'll go on to part number 2. See you there.